In Africa, a child dies every 30 seconds from malaria. It's an ancient killer, which has made an unwelcome comeback. In some areas, the disease is endemic, and precautions against it are part of life. There are, however, many parts of the continent where malaria breaks out intermittently. In these areas, loss of life is often higher because people are unprepared and drugs are not routinely available. If health workers had advance warning of where and when an outbreak of malaria was likely to occur, they could target resources much more effectively. Using satellites to predict malaria outbreaks could be a solution, and trials using satellite data are underway in Kenya, with the collaboration of the Kenyan Medical Research Institute.
I'm one of an international team of scientists looking at information that we can derive from satellites that's important for malaria. We use satellites because they're able to give us information over a wide area and on a repeated basis in a way which we couldn't get from any other means, for instance meteorological stations. The information that we get from satellites that is useful is temperature and rainfall and vegetation. We're interested in temperature because that affects the rate of development of the parasite within the mosquito, and we're interested in rainfall because that affects the availability of breeding sites. Vegetation is slightly more complex, but we're interested in that because it tells us about humidity, which affects survival of the adult mosquitoes.
Malaria is passed on by female mosquitoes, which carry the tiny parasite that causes the disease. The life cycle of the parasite and its host are affected by changes in climate. For instance, cold areas at high altitude can expect an outbreak of malaria if the temperature increases, because the malaria parasite can't breathe at low temperatures. And very dry areas can expect an outbreak if rainfall increases, because mosquitoes breed in stagnant water. But most of Africa lies between these extremes, which makes predicting malaria outbreaks much more difficult. So scientists are building a mathematical model to identify factors that encourage the proliferation of mosquitoes and parasites.
We're using the satellite data in combination with historical information on past outbreaks, as well as our understanding of the life cycle of the mosquito and the parasite, using those as inputs to a mathematical model, which we then use to try and predict where and when likely outbreaks of malaria will occur.
The model is beginning to show clear links between satellite weather patterns and outbreaks of malaria. The next step is to develop an early warning system that will protect vulnerable groups, such as pregnant women.
Now that we know that the model is feasible, we're looking for pilot areas in Kenya where we can test if the model works in the field.
The hope is that it will give health workers sufficient time to implement cost-effective control measures. Bed nets, for example, protect people from becoming infected and prevent outbreaks of malaria. Mosquitoes and malaria parasites are resistant to drugs and insecticides. So a satellite early warning system that gives people time to protect themselves could be an effective way of tackling a disease which is one of the world's biggest killers.